Hey kiddos, I am just making this video for you today for truncated cones. Okay, so let's start by filling in our table of contents if I can get there. Okay, so let's see. Today is the 25th, and this will be pages 16 to 17. Okay, so we're gonna hop to page 16, which in here is 17 because I must have added something. Okay, so the other day when we were doing our cross sections, we talked about truncated cones. Okay, truncated cones. Well, we know what a cone is. Okay, that's like, what we see down below here. Okay, oopsie doodles. Okay, however, truncated, what that literally means is you're just like lopping off like that top pointy part. So you cut off the top parallel to the base. Okay, anytime you're truncating something, you're lopping it off, you're cutting it off. Okay, so the best way to describe a truncated cone is the shape that a cup is in. Okay, so if you have a cup, like a drinking cup, think about like when you go to a water jug or something, the cups that you get. The reason being is because the circle on the bottom is smaller than the circle on the top. Okay, but here's the thing. Okay, we can find the volume of a cone, but then like now if we lopped off the top, like how do we find the volume if now there's two different radii? You know what I'm saying? So we are going to talk about that because I have the answer for you. So what you will need to do is you need to find the volume of the entire cone as if it wasn't being lopped off first. And then you subtract the volume of the top, the one that's being cut off. Okay, and voila. Now you have the volume for the truncated cone, but we are going to try it in baby steps. Okay, so this one's the easiest out of the two because we can literally see the two cones being made, right? So we're not really looking at the truncated part itself. We're looking at the entire cone. So kind of like when we were talking about like the entire for trig, like we had entire and then we had part, right? So it's kind of like that. We're not looking at the cutoff part. And then we're looking at the smaller one. Okay, so there's an entire cone and then there's like the cone that's lopped off at the top. So we need to find the volume of this cup to the nearest cubic centimeters. The dotted lines are saying that's where it's lopped off. Okay, that's where it's truncated. Oh, look at a new nerdy word. Okay, so here's what we're going to do. We're going to find the volume of the entire cone first. So I'm just going to call it VE. And that's 1/3 pi r squared h. I know this formula because it's given to me on my reference sheet. Okay, you could trust me or you could look if you choose. Okay, so now the entire one is the green here. Okay, now this kind of went off to the side over here, showing us like the cross sectional, just so that we can see exactly what it's saying and how to picture it. So we have 1/3 pi. The radius of the big guy is 7. Okay, and that's up here because that's at the top. And then the height of the entire thing is the 28. Okay, if I were to plug and chug this into my calculator, which I very well can, okay, I'm going to do 1/3, pi buttons down here, times 7 squared times 28. Okay, so I get 1,43676. It would keep going on and on and on because pi is an irrational number. So about 1436.76. Okay, so that's what it is for the entire thing. Yes, sorry, I keep getting emails up the wazoo. Okay, now we're going to go for the smaller one. So I'm just going to call this V sub S. It's still a cone. Okay, so what was lopped off is still a cone. So we're still using the cone formula. But now, since we went further down the cone, the radius is different. So the radius is going to be 3 squared. Or the radius is going to be 3, sorry, you square it. Okay, and then the height of the smaller cone is 12. Okay, so if we were to plug and chug that, and again, I work smarter, not harder, so I'm going to be a little lazy here and just kind of edit it. 3, 12. Okay, so it's 113.097 about. 113.097. Okay, it keeps going on and on and on. But now we just want the volume of what's left over. The volume that's left over is this on the top. Well, the top of the, I guess if you put it upside down, it could be the bottom. It's just all relative. Okay, so you just want that. So what you want to do is you want to take the whole cone and you're taking off the bottom. So you're subtracting the smaller one. So to find the total volume of the truncated cone, it's just the volume of the entire minus the volume of the small, which we already have those written up there. So I'm not going to rewrite them. What I am going to do is I'm going to go on my calculator and I'm going to scroll up to 1436.76, dot, dot, dot. Okay, I'm going to press enter. Then I'm going to subtract, go up, press enter. And I'm going to press enter there, and it's 1323.66. Oops, sorry. Okay, so 13.3.66, but they want it to the nearest cubic centimeter. So that's like the nearest whole number. So this turns into 1324 cubic centimeters. That's it. Okay. Now, let's check to see the ratio of the two cone heights in simplest form. Okay, so we have the entire cone and then we have the smaller cone. So the ratio of those, well, the bigger cone, the height is 28. And then the smaller cone, the height was 12. We could put that right into our calculator if we want to, and it simplifies it for us. It's 7/3. Now, what's interesting, so this is the height of the entire and the height of the small, right? That's what that is. Okay, but what's interesting is that if we found the radius of the entire and the radius of the small, and we divided them, like set it up as a ratio, it's also 7/3. Okay, so what that, and it's just off by, you know, we're just, it's off by a multiple of 4. So the reason why this is, okay, y is the same ratio, y, okay, and that's because the cross-sectional triangles, okay, meaning like what we see right here, okay, the flat ones, okay, so the cross-sectional triangles are similar. If they're similar, they're dilations of each other, so they have the same scale factor. Whoop, whoop. Okay, so that means they're always like, you know, we're going to be multiplying the ratio by 4 to get to the heights. So the scale factor would have been 4, right? To get from the smaller one to the big one. Okay, so realistically though, in real life, we're not going to know what's lopped off. Okay, we'll know the radius of the bottom, but we won't know the height of the smaller cone. So the height of the smaller cone, okay? Because we can't see how much is cut off. Can't see how much it's cut off. Okay, so because of that, we need to do problems that are a little bit more realistic, like that we won't have the height that's being subtracted. Okay, so in the following cup problem, a cup with a height of 18 centimeters has a large radius of 5.4, so that's on the top, and a small radius of 3 centimeters, okay? And notice just the height of the cup is the 18 centimeters, okay? Now, we don't know how much of the bottom is being cut off, right? That's what we said our unknown is. But if they are similar shapes, okay, we've been dealing with similar shapes pretty much all year, been giving to you guys on Delta Math. You're probably like, oh, this is terrible by now. Okay, but look at these two similar shapes. So if I did the big guy, and it does end up being a right triangle, okay, I'd have 5.4 on the top. Okay, that should be a 4. That looks more like a 9. Okay, that's 5.4 on the top. Now on the side, I have this unknown height that was lopped off, but then I also have the top part of the cup. So this side is 18 plus, or x plus 18, or 18 plus x. You could say either or. Now we have a smaller triangle. It's still a right triangle, and it does make it similar because like what was lopped off was parallel. So the top is 3, the side is x. So in part A, it says set up and solve an equation that can be used to find the value of x, which is the height of the smaller cone. Okay, so let's take a peek. If we have similar shapes and we're trying to find a side, we can use proportions. Okay, so I would set up x plus 18 all over x equals 5.4 over 3. I don't want to solve this on my own, so let's plug this into and solve. Gamma x, do it for me, my lovely calculator. Okay, and solve, parentheses. I'm going to do control divide. And I'm going to have x plus 18 over x equals, control divide, 5.4 over 3, comma, x. Sorry, loves. Okay, and you get 22.5. Okay, so that height, or x, is 22.5. Cute. Okay, so we know now that this is 22.5. So we know that the bottom is 22.5, and then the height of the whole thing, just add those suckers up, 18 and 22.5. So I would get, let's see, 40.5. That's right. Yes, that's right. Second guess myself every time. Okay, my loves. So we have everything that we need now. Okay, it says 1 liter is equivalent to 1,000 cubic centimeters. Can this cup hold more than 1 liter? Justify your answer. Well, let's see. The volume of the large cone, okay, we're still using 1/3 pi r squared h. So it's 1/3 pi times 5.4 squared times the height of the large one, which is 40.5. Okay, so I'm going to plug this in. Let's see. 1/3 pi times 5.4 squared times 40.5. Okay, so I get 1236.72. It probably keeps going on and on and on. Okay, so it's about 12 36.72, something like that. So now let's find the volume of the small. Okay, so we have a large cone and we're lopping off a small cone. So it's 1/3 pi r squared h, which is 1/3 pi. The small radius is 3. The height is 22.5. Okay, and then we just plug and chug. And again, I work smarter, not harder. I'm trying to save time on this. What was it? 22.5? Yep. Okay, so I get 212.058. Okay, so now the volume in total of the truncated cone is just the volume of the entire cone minus the volume of the small cone. We already have those values in our calculator, so just go up, highlight, press enter, minus, go up, highlight, press enter, and we get 1246.66. Okay, so 12, wait, is that what it says? Why do I second? Oh, 1024. I don't know. 1024.66, and that's cubic centimeters. However, that's not the final question that they're asking. They're saying 1 liter equals 1,000 cubic centimeters. This holds over 1,000 cubic centimeters, so it can hold more than 1 liter. So this is yes, and hold more than 1 liter. All right, all right, all right. So this last one, okay, this last one that we're doing. Ooh, I don't know why it, oh, boo, that was supposed to be on the next page. That's okay. Stuff happens. Okay, anyways. So again, baby steps. So we were given it with the actual height that was lopped off. Then the next one we had to put X for the height that was lopped off. So now this last one, we have to do everything on our own. Okay, so this is a cup. Cup is just a truncated cone. Okay, I want you to be very comfortable with saying that about a cup. You're going to go home and you're going to be like, can I have my truncated cone to fill it up with water? And then people are going to look at you like, what are you talking about? And then you're going to be like, IDK. That's what Miss Scrooge, she told me. And then I'll be like, IDK. That's what yes, that is what I told you. Anyways, okay. So let's see here, my love. So we have, I want the cross-sectional right triangles. So this, right? The whole cross section would have been just a triangle, but since I'm looking at it with the radii and stuff, I want to make sure that it's accurate. Okay, so let's talk about the radii. So this one is 4 because it's half of 8. This one's 2.8 because it's half of 5.6. Okay, we have that. Beautiful. We also have this part is 15, but we don't know this bottom part. So this whole thing right now is just X plus 15. But what we should see in this is that there are 2 similar triangles. So we can set up a proportion. Okay, the similar triangles are the entire and then the small one on the bottom. Okay, so let's set it up and solve. So we have X plus 15 over X equals 4 over 2.8. That's going to help us with the height, so I'm going to end solve this. Okay, so let's do that. I get x plus 15, oops, over x equals 4 over 2.8. Oopsies, what did I forget? Comma x. Okay, ooh, that's a nice number. 35, right out. So x equals 35. So what that means now is that this height is 35 and this one is now 50. Yay, we're almost there. It doesn't feel like it, but we are. So if we found the volume of the entire cone, it's 1/3 pi r squared h, which is 1/3 pi, the bigger radius is 4, you square it, times the height of the whole thing, which is 50. Hopefully you guys are comfortable plugging this in. I already did. Save some time. So I got 837.758. Keep going on and on and on. The volume of the smaller is, again, it's still a cone. So it's 1/3 pi r squared h, which is 1/3 pi times 2.8 squared times the height of the smaller, which is 35. And again, I've already done this. So hopefully you guys are comfortable plugging it in. I'm just trying to save some time. So now the volume of the truncated cone, okay, of the cup is just the entire minus the small. Should have them in your calculator. Go up, highlight, press enter, subtract, go up, press highlight, press enter. So I get 550.407. And we want to the nearest cubic centimeter. So that's the nearest whole number. So this would be about 550 cubic centimeters. And that's it. Okay, so hopefully that made sense. Yeah, and if you guys have any questions, never hesitate to ask me. If you need me to go through it on Tuesday quickly, we can absolutely do that. But Tuesday we are looking at doing a discovery activity. So that one will be good. We're kind of doing it together, but I don't know. It's fun. I think it's fun. You guys might not think it's fun, but I do. Okay, my dears, have a great long weekend and I will see you all Tuesday.